Surface area of pyramids. How does finding the surface area of pyramids compare to triangular prisms, and how do they differ? Okay, so today our focus is a pyramid and not finding the volume this time. If you recall, last time the volume of a pyramid was 1/3 the area of the base times the height, right? So this is not the case this time. This time we're not talking about volume. We are talking about surface area. Okay, that's the outside of the shape. So in order to do that, I'm going to show you here that I've got a pyramid, and you need to know that the sides over here are called lateral face. Let me see if I can find a better image for you. So check out this image here. So I've got this another pyramid here, and so you can see this triangle right here, this side, almost like the right side of this triangle. This is going to be considered a lateral face. Okay, it's kind of on its side. Here's another triangle with their lateral face. So these two you can see, and then in the background, and I'll just trace it. It's in the back, goes in the back, comes back up. That's another lateral face, and then there's one more this way, another lateral face. So 4 lateral faces because it's a square pyramid. So I'm going to come back to my beautiful drawing, and I'll show you the net image of this. So if I were to cut this up, right, if I were to slice it right down here, right down the little edges here, and open it up, it should look like this, where each lateral face opens up, and I've got 4 triangles, and then I have the square here in the middle. All right, so it's important to understand that if you break that up, it's really not that difficult to find the surface area. Really what you're going to do is you're going to find the area of this inside base, and then you're going to find the area of one of the triangles. If you can find one, you just multiply by 4, and it gives you your total surface area if you add everything up. Let's go and try an example out. All right, so find the total surface area of this pyramid. All right, so I'm taking a look at this square pyramid. I'm asking for surface area. So what I'm going to do is I'm going to break this up. I know that the base here, I'll show you all my work at once. My base here is 4 by 4. That's this base down in the bottom. Okay, that's 4 by 4, so I already know the base is 16. Next, I take a look at one of the triangles that's kind of on its side here, if you will. Well, the slant height, not the height of the pyramid, but the slant height happens to be 9 inches, which is actually the height of the triangle. The base I already know is 4, so I can use the formula for a triangle to find out that the area of this particular triangle happens to be 18 inches. 18 square inches. Now, there's 4 of these faces. Remember, if I broke this back up, there's going to be 4 of the triangles there to make that pyramid. So in this case, I go 4 faces. That's 4 times that 18 I just found. That's 72. And so those are all the lateral faces. 16 is just the base. And if I add everything up, I get 88 inches squared. There's really not much more to it than that, but there's 2 more examples I'm going to give you. Okay, so here's another one. This time slightly different. The base, if you notice here as I shade it, happens to be a triangle. Okay, so I've got to kind of split this up into smaller pieces. So I'm going to take a look at the base. I'll show you all my work at the same time. I say, all right, so I've got this triangle here, and this is not really drawn to scale. It really should be an equilateral triangle. So it would more be out, but that's okay. Just trust me there. So I'm going to find the area of this base, 16 times 16, and then half of that. That's the area of my base, 128, the shaded region. Now, as far as the sides going up, if this was a really equilateral triangle, which it doesn't look like it, would probably be more like where this is 16, this is 16, this is 16, and they all come to a point. If that's the case, then all of these triangles, these lateral faces here, are going to be congruent. They're going to be the same. So if I just find one of them, so I find one of them by saying, look, I need the base, which is 16. I need the height. So one of these triangles is 16, and it goes up 20. Well, 16 times 20 and cut in half gives you 160, but I have this time 3 of those sides. 1, 2, 3. 3 of those sides. So I multiply by 3. I get 480, and I add it to the base I originally found. I come up with 608 meters squared would be the total surface area. All right, let's do one last example. Sonny here is camping. No, I'm sorry, camping. Wrapping a gift that is in the shape of a square pyramid. The slant height is 3 inches, and the base of the edges is 2 inches. How many square inches of wrapping paper does she need to cover it? All right, so I first start off with drawing a picture. It's a square pyramid, so draw a square, right, at an angle, if you will. Pick a point, and you make a pyramid out of it. The edges were 2 and the slant height is 3, so right away I know the base is just 2 times 2, 2 times 2, that's 4. And that one of the sides of the triangle, there's 4 sides. One side happens to be a base of 2, a height of 3, so I find out that the area is 3. And then there's 4 of those, right? 1, 2, the back side, and the left side, so 4 of them. 3 times 4 is 12. Add those together, and that gives my final surface area. So remember, this is really for any shape. You cut into its pieces until it's flat pieces and find the area and add it all together. All right, that's it for notes today. See ya.